Welcome to a new test and teardown video. This time it's another power supply from Oltronix in Stockholm, Sweden. This is the model B60-1T. And if you search around in my YouTube videos, you will see that I already had another B60, but it was quite different from this one. So this is a whole different design. It's actually really heavy. And this one, it's quite special. This switch here, that will be the output modes, ranges and all that. It is a mega long multi-switch. It's connected to a lot of things inside the unit, and I can tell you all about that later because I got full schematics. Thanks a lot to my Swedish friends. I got a really good schematic, and I will put this online and send you a link so you can read this in full super duper quality. Yes, and of course it got current limit and dual display. As if I move it, see the needles, they work, so I really hope I can make this one work. Yeah, this one can go to, you can see a lot of volts here. This is just the dial up here. So this is how you program the voltage. And as you see here, if it is in 10 volt mode, then of course this is 0 to 10 volts. But of course you need to have a 0 or an off, and then you can have 35 volts out, and then your meter and your dial is 100 volts full scale, right? So you can imagine if you set this to 10 volts and then you dial this 2 times, then you have 35 volts or 70 volts. And here is the thing. There's also a tap on the transformer, and this is also handled by this. So you see here, that is of course the meter, but it's also here, it says this is your output. See, 6 volt 4 amp, then off, 30 volts 2 amps, or 60 volts 1 amp is what this nice linear power supply can do. And it's all transistors, no fancy smancy op amps or anything like that, if I have the right schematic version, because some of the Oltronix schematics, they evolved over time, and so I actually had a few schematics that didn't match my units. Yeah, what else can I say? This unit is from 1970. 1970. Oh, this is... Oi. Oh, and this handle here, see, it's not really in balance. And this is a classic Oltronix case. Nice profile, aluminium and all that kind of stuff. We got... Ooh, what is that? I was just going to say, ooh, this is where we got the big capacitors mounted. But there is something I need to repair here, and a fuse. They are sometimes a little bit funny to open. I'm gonna go and open first and have a little inspection. So this is a classic way to get in. Only 2 screws here at the back, and then you just slide out the cover from the bottom. And it has been modified. See, this is where the original capacitors, so those are the capacitor screws, and then originally I would assume you had like 2 really big capacitors here, but now the 2 capacitors, they are mounted here. This is clearly a modification, and there's a piece of aluminium bracket that holds this big reefer capacitor here. Definitely not original. And that one, look at that funny mounting. Somebody did spend quite a long time to do this, but just didn't do it like super beautiful. But anyway, it's done. And they made a bracket that, and this took quite some while to figure all this out. Yeah, and that is the mega switch I mentioned. All those different sections, they consist of half of the switches. So that will be 1, 2, 3, 4, 5, 6, 7 sections of that switch. Quite a lot of wires here. And that is one beautiful transformer. Look at that. It is also quite heavy, this one. So what we got over here, I bet that will be current sense resistors. Something like that, right? Some bendy metal that is soldered somehow or glued to the circuit board for sensing the currents, or for the amp meter ranges, probably, right? See, we got some repairs and some nasty leakage. That is not so good. I'll try my best and see if I can clean all this up. And where's the source of this problem here, right? It looks a little bit like a bird dropping or something like that, right? Ooh, this is bad. But there's a capacitor here. On the other side, that one down here, this little blue one, or that one. Yeah, where's the source of the problem? I can't really figure that out yet, but I want to inspect all this, try and clean all this up before I power it up. Oh, there we go, all the transistors down there. So, oh yeah, okay. This is also a classic Oltronix. So you pull out, yeah, okay, yes, you could do that. Normally they, yeah, here we go. So that will be the transistors. Also, this one contains some really weird over voltage protection stuff on the schematic, but I can't see exactly where it's connected and so on. So yeah, stay tuned for more. So that will be the capacitor holder nuts here, right? And one of them that was really loose, and it turns out they only cut down one of them for the correct length. So that one could reach inside that, and the other one they forgot to do it, and then maybe another day and they never did it. So that is something that I can easily fix. Also, I can show you the circuit board is hinged, so you can just move it out, and then you can have a better look, and then you can do all your service and measure everything and fix this and that. I should probably show you the circuit board here. Is actually quite beautiful. See, only transistors and all the good things here. We got quite a lot of trimmers, and I should probably show you the schematic, and then we can have a little deeper dive into the schematic. Oh yeah, look at that. We also got some more of these current sensing measurement resistors and all that kind of stuff. That is some interesting way to do it, huh? And that is the high precision potentiometer. Oh yeah, did I tell you that I already cleaned up this area? See how nice and beautiful it is. I'm gonna give it a nice thick layer of varnish once I get this up and running. It's a little bit funny, this little locking here. But anyway, kind of works all right. I think we should just try and power it up. Are you ready? So here is how I prefer to do the first power on. I will of course crank on line, and I am now in the 6 volt 4 amp range. I crank down voltage to 0. Current limit is here in the middle, more or less. And then I will crank down my variable mains. And then I will slowly, here we're going up. And we don't see, yes we do see some. Here at 70 volts we see 0.6 watts. And this tells me the fuse is okay, voltages goes up, everything is good and fine, and I am at 150 and 2 watts, and I just go on and go on, and as you see here, so that is 220, and it's using 3 watts idle, and let's try and dial up here. Oi! We got a little bit of a loosey. This can't be a good sign. So what you see here is a completely... Okay, it says 2. Hey. Okay, now it works. Ooh, this potentiometer is completely wasted. Look at that. And this is a yes, see? This is a classic power supply error in the design. And it's made so when the wiper disconnects, you get full output voltage. So when you're trimming down here for something really, really important, then suddenly you get these, see? Sudden spikes. And this is a closed, see? This is a closed precision potentiometer, so you can't really repair it or something like that. You need to replace it, and they're very, very expensive, especially those super linear ones. You can see this. So that is, it's actually a lot easier to see here. Oh, the amp meter just goes. And there was a lamp in here that went on. So when it is in current mode, there's a lamp. How about if I crank down the... I think it's time we go and load it a little bit, but I will just put it for something and then we'll see what happens. So I think I'm ready to try and load it a little bit. Let's just turn on my load and give it a little bit. 100 milliamps. I was hoping I could go into current mode, but that is not the case. So that is interesting. And let's just give it 200, 3. Okay, now can I go? Nope. See? That is an interesting indicator of what I need to do. 4, 5. Okay, where are we? Oh, look at that. Okay, so the current limits for the 4 amp mode. See? There's a lamp here. I don't know if you can see. There's a lamp and it shows here and it's in constant current somehow. But there should also be a lamp here on the right that says constant voltage, and that one is not. I think so, this one. Oops. Okay, so that seems to be working. The output voltage here is quite stable. Look at that. If I turn off, the reason, oh, okay, this is me who's, okay, hang on, I'll see the difference. I put now my amp meter here and my load here, and then I'm measuring voltage here. What I did before, I just plugged it in my voltmeter, man. That is stupid, because you got actually resistance in the cables. So now you see the difference. But still, you see a tiny little bit. And that can, of course, be removed completely by screwing on here voltage wires to your voltmeter directly all the way down here, and then pull the current up here, right? Then you'll be closer to the feedback where you're measuring the voltage. This will give you a better view of what's going on. So I mean, the low voltage mode, it seems to be working. We are at 4 volts, so this is a little bit more than half. So here's my idea. Now I go off. Oh, it goes in, this lamp is on. Now I will switch it to the 35 volt mode. Voltmeter hammers up and we get 46 volts. Ah, that is because the dial can go to all the way, but the meter can only go to 35, and that output here was only supposed to be able to give you 30, but it can give you a lot more. So at 30 volts, let's try and give it a half an amp. Yeah. Good. So what happens if I... Ah, yeah, okay, it's the same dial, obviously. Okay, good. But now the meter goes down, because now I have a meter that can go all the way to some more volts. Oi, oi, oi. It was supposed to give only 60, but it can give probably more than that. But let's see here. Ooh, a half an amp at 70 volts. That is sexy. But let's see. Okay, the meter only goes to 70. So I'm of course not able to... I shouldn't do that because now the meter is overloaded. But there's definitely something here with maximum voltage settings. And there's also something with this potentiometer being bad. But it seems not to be so bad. Okay, here it is. All the badness. If you can say that. Can you even say that? I can't adjust it, but look at that voltmeter here. I don't know, is this easy to see? Ah, my hand is in the way. How can I be here and... Yeah. But that is definitely the voltmeter here. Going... See? Ooh. Those jumps are nasty. So full voltage jumps. So this potentiometer is completely dead. And there's nothing I can do to fix that. So that is why it was thrown out. And now it is in my lab for figuring out what to do about it. Well, let's see if we can find another potentiometer. I don't know. So here's 70 volts, 1 amp output. So that is 70 watts output, right? From a linear power supply. We are very close to the maximum voltage rail. So this means the input power is only 86 watts. Isn't that just amazingly impressive? Of course, if I crank down the voltage now, it's gonna be the same input power, and you're of course going to see a whole different picture. But that's just a little funny, isn't it? That was a good picture. So I cleaned up the potentiometer for the voltage. It turns out there is actually an opening in the end of the potentiometer where I can access. Let's see if I can open this. Where I can access the potentiometer. Look at that here in the end. This hole here. So I sprayed in some cleaning, some contact 61, and then massaged the potentiometer 2 times, and now it works perfectly fine. Super stable voltage and all that. So now here we go with the current limit and the constant voltage indicators, and that's of course bulbs, as you see here, and they are connected to the positive 22 volt rail from the auxiliary supply, and the 2 ends of the 2 bulbs goes to a little kind of flip-flop look-alike driver circuit, and one of the bulbs is of course open, and I think I can fit in a 5mm LED here instead. That will be a much better solution, and then I can adjust the with some series resistors here to make this work. This is my solution with LEDs in there. I had to use a little bit of resistors here because I needed to have a minimum current because of the transistor circuit around those, the switching transistors for the voltage and current modes. And then I wanted a little bit more current in the green one instead of the red one. Yeah, I'm using colored LEDs. So let's try and turn this on. And I don't want this to be really bright because it's gonna shine directly to some plastic down here, and it's really annoying if it's too bright. But at least see, this is voltage mode and then current mode. So it's ready to be assembled again. Now look at this. It's not super bright, I must say, but it's at least working, right? So this is a voltage mode and this is current mode. I can easily see what is going on, and it's also clearly show that the unit is powered on. So yeah, it is definitely working again. Here is the schematic of this Oltronix power supply, and what I wanted you to see is this is the fantastic switch for the different voltage ranges. And if you see here, we got 6 volts, off, 30 volts and 60 volts. And of course they paralleled 2 of the sections for the transformer, the bridge rectifier system. And yeah, we can see the next section of that switch. Again, in off, there's actually a discharge resistor that discharges all the voltage on that capacitor. So that means you're going to have a peak current pulse when you go from off to 30 or from off to 6 volts. So that is something that will wear down this switch over time. I mean, it could have been smarter to have some sort of a resistor that sort of slowly made it between those 2 voltages, right? Yeah, that's just how I would have made it, because this is yeah, a little bit crazy, but okay, there's an off there anyway. And here's another section. This resistor here is used for setting up the current limiter, as you see here. And then here, remember the voltage setup, a voltmeter is here, and then this is the multi-turn potentiometer, and it just continues with this fantastic switch all over the place. It's also here. This little circuit here is over voltage protection, and it is not really clear where it is connected or how it is connected to anything. I mean, something must be missing, but I think this circuit here is connected to the output, and somehow it is programmed to start drawing a lot of current, because this is what it does when it is in 6 volt mode. It draws a lot of current when the output voltage is more than 7 volts, and you can see this current on the amp meter. So that is just a funny little extra circuit for that. And yeah, that's just more or less yeah, I think this schematic is quite interesting because it's just all transistors, as you see here, and they are very, very happy about this coupling here with the 2 emitters together. So this is a differential amplifier, and so it compares these 2, and then yeah, you see here, they're doing this all over here and all over here, and again, and even they're doing it also. That will be the 2 lamps for constant voltage and current limit mode. And this is where I changed the 2 lamps to LEDs. And of course you need to have a little bit of current here for this system to work, and also for the 2 emitters to pull this point up, and this way it switches over correctly. And yeah, if the constant voltage bulb is not working, then there is this resistor here, so you can actually see what is going on. And if you want to debug this, sorry that they didn't really put in a lot of measure point and any voltages and stuff like that, but I can tell you we got about 22 volts on this capacitor here, because this is what we got on the bulbs. I didn't really measure anything else because it's really working. Yeah, yeah, we could probably see here. That would be the resistors for the current sharing and also the amp meter. You see the two output transistors, and then it goes to all those resistors here. They are the metal things that is bent and glued to the circuit board, and then you share the current real nice with your output. This is of course the output. So there's another little funny thing. You can imagine if you have full output voltage like 60 volts, then you go down to 30, and of course the system here will slowly discharge that capacitor, and then when you go from 30 to off, you can now see what's going to happen here. You have 30 or 40 volts on the capacitor here, and then via 5 ohms hammer discharged. So the peak here is quite high, right? But if you also have this voltage on the output, see, we got 1000 microfarad here on the output. The output here goes all the way up here, and then there is a 1 amp diode that discharges the output. Whatever you have on the output goes via this 1 amp diode via 5 ohms to ground when you go to off. So I don't know how long this diode's gonna last, because that is quite a lot of overcurrent, wouldn't you say? Oh, yeah. And that is, of course, over temperature. So I think I'm done with this video now. I wanted to show you a little thing. After I explained you the schematic about this on-off switch, I think you can actually hear what's going on here. So try and listen. Can you hear it? Flame. Splat. Every time you go to off from the high voltage, it's just like splat. So it's definitely going to eat that switch somehow. So it's not the most perfect design anyway. Thank you very much for watching. See you around. Bye bye.